9.6 is about dilations. If you think about if you go and get your eyes checked for glasses, sometimes they will dilate your eyes by putting drops in them. What that does is it allows your pupils, the black part of your eyes, to get bigger so that the doctor can see inside your eye. So a dilation is a changing of the shape. It can either enlarge it, like with your eyes, or it can make it smaller, which is called a reduction. If you read our little definition, these two triangles have been dilated. If this bottom one is my original image, it has been enlarged to this larger triangle. When we dilate in math, we dilate it about a point. In other words, there has to be one place that we're sort of stretching it out to enlarge it. So let's see if this top shape really is a dilation of the bottom one. I'm going to take my ruler and I'm lining it up just along this vertex over here so that they're both touch. And I'm just going to sketch a little line. I'm going to do the same thing through the top of the triangle. I'm going to line up my tops and sketch a little line. Okay, let's do this last side over here. Line it up. And hey, you see how they all meet down here? This point is C, the center of dilation. That's how I made my figure bigger. They use this a whole lot in drawing and animation and things like that. Now, how much bigger it got, I don't know, but that's what we're going to do in example 1. We're going to dilate this trapezoid by a scale factor of 3. That means our new trapezoid is going to be about 3 times the size of this one. So let's give our trapezoid a name. Let's call it PSRQ or PQRS, depending on which way you read it. And over here on the right side, we have steps. Step 1, we're going to say we're going to measure with a ruler from P to C. So with my ruler, I'm going to use inches, and I'm just going to line up C and P right here. And when I measure it, I see that that line is about 3/4 of an inch long. So a scale factor of 3 means my new line has to be 3 times that length, which is 9/4. So if you line it up so it's on the same angle, okay, we're going to go 3/4 of an inch, 3/4 of an inch, 3/4 of an inch. 3 of my 3/4. Here's my new P. P prime. So what did we do? We multiplied by the scale factor. Now I'm just going to abbreviate SF. And then we plotted point P prime, our new P. Okay. Our third and final step, to finish this off, we have to repeat what we did with other points. In our case, we have 3 other points. So let's measure again from C to S. Okay, I can see it's about 1¼ inches long. So we're going to repeat the same thing we did. 1¼ 1¼ 1¼ Here is my new S. Okay, let's do the same thing with R, and yes, this will go into your steps, and I'm sorry. R is also about 1¼ inches. 1¼ 1¼ 1¼ Here's my new R. And then lastly, we're going to do it with Q. And C to Q is about 1 inch. So our new line has to be 3 inches long. Right down here. Okay. Now with a colored pen or marker or highlighter, I'm just going to draw my new image. So PQ is the base, so I'm going to line up P and Q. And SR is another base. And then I'm going to just connect my dots. And I have this much bigger trapezoid. And I can see it is a lot bigger. And how much bigger? It's 3 times bigger. Okay, so let's do example 2. Example 2, I have a single-celled organism. Here's my little organism. And it is 200 microns in length. Okay, a micron symbol kind of looks like a J with an M attached to it. I am looking at it in a microscope, and in my microscope, it appears that it is now 50 millimeters long. So that's a big increase. But how much of an increase? Well, in order to find the scale factor, I have to have the same units. Right now I have microns and millimeters. So since my original shape was in microns, and I have this scale right here that they give me, I need to change millimeters to microns. Okay? Well, how do I do that? Well, if 1 millimeter is 1,000 microns, I can multiply 50 times 1,000, and what do I get? I get 50,000. So this is 50,000 microns in length. Wow, that's a lot. It doesn't answer my question though. It says, what was the scale factor? Okay, since I made it bigger, my scale factor is going to be bigger than 1. So to find the scale factor, I have to place 50,000 over 200. I will find that my scale factor is about 250. It's 250 times larger. Okay, last example here. I'm going to let you read the top and plot the points. So first, let's plot our original trapezoid. I'm going to use sparkly blue for that. Make sure you label your points. Okay, use a ruler, please, to connect your points. And you should have a nice little slanted trapezoid here. Okay, there's my trapezoid. and I want to dilate it about a scale factor of 1/4. So my little hint up here, dilations in the coordinate plane, says how I do this is I multiply each coordinate by 1/4. So if E is -8, 4, and I multiply everything by 1/4 or divide it by 4, -8 divided by 4 is -2, and 4 divided by 4 is 1. That's my new E point. Let's do F. F is -4, 8. Multiply it by a scale factor of 1/4. So divide -4 by 4, -1. 8 divided by 4 is 2. My new F is at -1, 2. Okay, and G, the 0.84, dilated by a scale factor of 1/4 is going to be 2, 1. And my last point, -4, -8, is going to be -1, -2 on my coordinate plane. So I'm going to use pink this time, a different color, to label these points right here, my dilated image. So I've got -2, 1. I've got -1, 2. I've got +2, 1. And I've got -1, -2. So here's my new trapezoid. And you could see it is quite a bit smaller. How much smaller? It's 1/4 of the size of the original trapezoid. So remember, if you're dilating in the coordinate plane, just multiply each coordinate by the scale factor.